Hello students, today we are going to start quicksort algorithm. Quicksort algorithm is basically divide and conquer technique. Now first we will see what do we mean by divide and conquer techniques. It is a widely used sorting algorithm that makes n log n comparisons in average case for sorting an array of n elements. It is a faster and highly efficient sorting algorithm. This algorithm follows divide and conquer approach. Divide and conquer basically is a technique of breaking down the algorithms into the subproblems and then solve each subproblem, combine the results back together to solve the original problem. Next. Now what we will see, what do we mean by divide? In divide, first here we are going to pick a pivot element. Now see students, pivot element can either be a rightmost element, can be a leftmost element, or can be an element at the center. So here in the example, I'll be showing you when we choose the pivot, which is the rightmost element in the list. After that, the partition or rearrange the array into two subarrays such that each element in the left subarray is less than or equal to the pivot element and each element in the right subarray is greater than, means larger than the pivot element. Okay. Now what do we mean by conquer? Conquer means recursively sort two subarray with the help of quicksort and combine the already sorted arrays. Now let's discuss this example students. Here we have a list of elements which we have to solve with the help of quicksort algorithm. Now in this list I have chosen 10 as a pivot element. Let 10 be an pivot element and we are using two pointers, say P and Q as two pointers. You can name anything to these pointers as I have given it P and Q. Now here you can see 10 is a pivot which is bold and P is pointing to next element of pivot, that is 16, and Q is pointing to the last element in the list, that is 5. Now we are going to follow one rule and the rule is element to which P is pointing is greater than the pivot. Then we will stop. Okay, if means this element, if it is greater than the pivot element, then stop. If it is not, then we will move ahead till we get the bigger element than the pivot element. Okay. And for Q, the rule is the element to which Q is pointing is less than the pivot element. Then we will stop moving. Else we will keep on moving. Okay. Once we stop for P and stop for Q, we will swap these two elements respectively. Next. Now see here. In first case, P is pointing to 16 and Q is pointing to 5. Okay. So as per the rule 1 that we have seen in the previous slide, here P is greater than 10 and Q is again less than the pivot. Now we will stop and swap P and Q. So I have marked it with red color font. Now here you can see at this step our list becomes like this. Now P is and Q we have swapped. Initially Q was 5. Now it is 16 and P is 5 as we have swapped P and Q because it has followed our rule. Okay. Now let's see the next step. In the next step, now you can see P is pointing to 8 and Q is pointing to 9. In the above case, now P is smaller than the pivot element which is 10. So we will move pointer P to the next element. Okay, whereas Q is pointing to 9 and smaller than the pivot element 10. So Q will not move. Okay, means now here Q is satisfying the rule 1. So we have stopped here for Q. But as P is smaller than pivot and in our rule, our P should be greater than the pivot element, then only we can stop. So in this case, now our Q will remain 9 only, but P will move to 12. See here. Now 8 is remaining as it is. Now my P is pointing to 12 and Q, as we have already stopped it at 9 as it has followed the rule. Now at this step we will swap element pointing P and Q. Okay, so now here P is 12 which is greater than 10, so P is stopped and P and Q will swap with each other. Now here you can see P is pointing to 9 now and Q is pointing to 12, means here we have swapped them. Now at the next step P is pointing to 15 and Q is pointing to 3. Okay, so P is 15 and Q is 3. Here both the conditions are satisfied, means P is greater than pivot and Q is less than pivot. So let's see, we have swapped P and Q. Now we will move pointer P to 6, but as per rule it is smaller than the pivot element 10, so we will stop. Now move the Q to 6. Now here we can find that Q is pointing to 6 but smaller than pivot, but P and Q are crossing each other. Now see student, this is a tricky case. Here P and Q both are pointing at 6 and they have crossed each other. Okay, so in such situation, means crossing means what? As I have said, P is smaller and we need P should be bigger. So P will move to 15 and Q has moved to 6, means P and Q have crossed each other's path. Yes. So when such situation comes where two pointers crosses each other, we will swap them in such a way that only Q will replace the pivot element. Okay, means here 6 is pointing to Q. So we will swap 6 with the pivot element. Now see here students, pivot is come at the place of 6 and 6 has placed at the place of the pivot element, but P remains at 15 only. Now you can see 6 is no longer pivot now and 10 has come in the center in such a way that elements that are present before 10 all are smaller than 10. You can see sublist 1 and sublist 2, and in sublist 2 you can see that all elements that are greater than 10 are shifted to the right side of the 10, means they have shifted in such a way that all greater elements are next to 10, means in the entire list 10 is the only element which is standing at its correct position. That means now 10 will not change its position. We have to sort sublist 1 recursively and sublist 2 recursively, and finally we have to combine the original result. That's what it's written over here. Here we can observe that element in sublist 1 are smaller than the pivot element, that is 10, and elements in sublist 2 are greater than the pivot element. That means we have divided the list into two halves, that is the divide, and recursively sort sublist 1 and recursively sort sublist 2 in the same way, that means conquer, and finally combine the result of both the sorted sublists, that is the combine. So this is how we apply the quick sort algorithm to the given example. I hope you have understood this video. We will see one more example in our next video. Thank you students.